Okay, greetings. This is Dean Carpenter, Program Scientist, the Albemarle Pamlico National Estuary Partnership, also known as APNEP. Welcome to the first and perhaps only presentation of the 2025 APNEP Science and Technology webinar series, sponsored by APNEP's Science and Technical Advisory Committee, also known as the STAC. I'll allow today's presenter to share with the audience details about his background, but know that Dr. Joel Fodrie is a professor of the Institute of Marine Sciences at the University and director of the Institute, professor in the Department of Earth, Marine, and Environmental Sciences and director of the Institute of Marine Sciences at the University of North Carolina at Chapel Hill. Hope I got that right. One career detail that I wish to highlight is that Joel served on APNEP STAC from 2009 to 2023. Note that this session is being recorded for later access by STAC members and other interested parties who could not join today. Recordings of webinars in the 2024 series can be accessed by simply visiting the APNEP website at apnep.org, selecting the Resources tab on the homepage, then selecting For Scientists tab. We do anticipate that there will be a 2026 webinar series. So please forward your ideas for webinar topics to me, and I will share with the STAC leadership for consideration. Now I will hand the virtual mic to Dr. Fodrie. Welcome, Joel.
Okay, thank you. And I'm going to try to share a screen for a presentation. Share. Entire screen. Perhaps y'all could let me know if. Okay, cool. All right. Yeah, so I am one of, I believe, 9 academic researchers that are finishing a multi-year study to evaluate the status of North Carolina's fisheries, its fisheries management, and our coastal resources like the habitats that support fisheries. It includes a number of people from UNC, and I know Nate Hall is in the webinar, as well as NC State, UNCW, and ECU. I will admit that in thinking about this is a talk that I gave not that long ago at the Water Quality and Fisheries Symposium. I think I'm talking to a similar audience, scientists and managers. So this is a focused presentation that relates to what I've learned in the synthesis study of the state's fisheries. But it's not just kind of a broad survey of, hey, we said manage fish like this with these sorts of gears. I wanted to use this forum for this audience to maybe share this message. And I'm not necessarily, I don't think I'm by nature a controversial person, but I do see, I'm very curious to your feedback because I am going to make a challenge to us. I think there's some challenges for us so that we can communicate to the legislature better, so that we get better results for our coastal systems. Okay. So when I put together this talk, again, for the Water Quality Fisheries Symposium, they had a tagline that you see here at the bottom, which says a science-driven perspective on, how we move the ball forward. And I was looking for an into that talk, and that science-driven, science-based is kind of something that I just started thinking about, or have been thinking about really for like 20 years. And so I really kind of wanted to start there, and I thought I might just reflect on a moment, well, what is science? There are different ways people can define science, and people often compare science to religion. Some people would say science deals with the natural world and religion deals with the metaphysical. But another way people define science is that you're gaining knowledge through empirical, either observation or experiments. And there's some sort of formal peer review. And in the scientific philosopher Karl Popper's terms, it involves things that we can falsify. Whereas religion, it tends to derive knowledge from sacred text or traditions, and it's not subject to verification. There's informal peer review through long periods of time, But we often, judge how good our science is and how we inform management as this criteria that we're scientists. So this is a paper and a paper that I often reference in a data set that I think is interesting. Back in the 1960s, this person named Platt wrote a paper about what is strong inference. Strong inference is the way that we move science forward through devising alternative hypothesis. And this alternative hypothesis framework is from another scientist, a geologist named Chamberlain, from a paper back in the 1800s. After you set those hypotheses, you devise the crucial experiment that allow you to eliminate one of those hypotheses. And then after you design the experiment, you perform it. And this allows sort of you to follow an inductive tree towards strong inference. And what I would say, the annotated version of this paper is that ecologists are really lagging behind the physicist and the molecular biologist. We seem to be struggling to move our field forward as rapidly as some of these other fields of science. That's a little hurtful. I'm an ecologist, and that's kind of a challenge to what I do to maybe do it better. And just to kind of build that case a bit more, what you see at the bottom is an analysis that was done about 10 years ago, just looking at this Journal of Animal Ecology, a really strong journal, really nice work. And at least in this 1 year, almost 80% of the papers that are in that journal, according to at least this one team, did not state a clearly defined hypothesis. Only 22% explicitly say, here's the thing we're testing. We are going to gain strong inference by designing an experiment around this specific questions or set of ideas. And so, I think there's something to be said there that we need to be like sharpening our knife in terms of how we try to attack these challenging coastal problems. I've lost my ability to advance slides. Okay. So I think for a lot of people in the room, what's near and dear to our heart is how this coastal system, this amazing, valuable coastal system, the Albemarle Pamlico complex that we have, how it supports fisheries. And what I'm showing you here is I'm showing you a figure from 1977 in which in the northern Gulf of Mexico, the amount of marsh habitat, that's on the x-axis, relates to shrimp hauls. And there's a really nice linear relationship here. One might say from this graph that the amount of habitat equals the amount of fishery production. I happened to be at a meeting last week, and I was talking to a guy named Don Bosch. If you look at the little yellow box, he published a follow-up paper with Turner in 1984, and they basically reflected that this relationship was really hard to map almost anywhere else on the planet. It had been fairly clearly observed in the northern Gulf of Mexico, but this relationship between habitat and fish is very, very hard to demonstrate. And so what we typically see is more graphs like this, really nicely drawn conceptual illustrations that are a hypothetical, a presumed relationship between habitat amount or habitat quality and fish reproduction. And this frustrates me to no end. I feel like as a scientist, to not be able to tell legislators, that if we lose X amount of habitat, we'll lose X amount of fish. If we restore X amount of habitat, we'll gain X amount of fish. My point is in some ways going to be that really limits our impact. That's a struggle that we're having to make arguments to legislatures who have to make tough decisions about how to manage a coast based upon ecological, societal, economic factors. And to the degree that we typically have to rely on presumed or theoretical relationships, it handcuffs us. So you might say that I feel like in the case of North Carolina and how habitat supports fisheries, we are almost in a quasi-religion. We have gained our knowledge from what equates to like sacred bumper stickers. This is a fabulous bumper sticker. I love it to death. Do I believe it has truth in it? I absolutely do. But I just use that keyword belief. I can't show you the graph that would link the amount of marsh habitat in North Carolina to the capacity of North Carolina to support fishery production. And we have never been able to empirically validate that if we lose half of seagrass, or we lose half of the marsh, or we lose half of our oyster reefs, that we can, with any quantitative sense, say how much fish we're going to have left to harvest in this state. So, yeah, what's this slide about? So I was listening to a podcast not that long ago with Michael Keaton, the guy who played Beetlejuice. And it was a fascinating interview because I don't know acting from beans. But apparently, Michael Keaton was told, so Beetlejuice is not from this time and he wears this suit. And Michael Keaton had to come up with what Beetlejuice looks like. So imagine that we were all actors and we show up to the set. This is $1 million project and this is our careers. And out walks Michael Keaton as Beetlejuice. I would have been like, what is this guy doing? Like, I mean, he's ruining my career with this crazy outfit and thing that he's doing. The point is that he was taking a big swing. Michael Keaton was taking a big swing and he landed. So if you'll give me like 10 or 15 more minutes, I really feel like I put my neck out there. I'm kind of taking a big swing with this audience of friends and colleagues to kind of, put it out there in a way that hopefully we can identify a real challenge and maybe find some solutions going forward in terms of how we support research and economies in the state. So again, if I'm out on a limb with this fairly provocative notion that we have a long way to go, I wanted to show you this quote. It says, conservation has developed poorly as a science in the sense that it has shown little ability or improvement to predict anything of importance. I mean, that's harsh. And you might wonder, who said this? It sounds like it could be a developer or somebody who's a real cynic. It turns out that the person that said this is a guy named Peter Kariva. And Peter Kariva is currently the CEO and president of the Aquarium of the Pacific, and he's more famously known as the former chief scientist for the Nature Conservancy, right? One of the leading organizations that's trying to do good to protect habitats and ecosystems on the planet. And it's possible that he said this decades ago in a weak moment. And as a matter of fact, he said it about a month ago when he was going to give a talk here in North Carolina. And he sort of focused his talk on this grand challenge of really trying to gain strong inference. Like, how do we go about figuring out how to get strong inference for these very challenging questions? So strong inference appears upon a clearly defined testable hypothesis or series of hypotheses. And what I am going to say to this audience is that it seems to me that we need better graphs such that we can plot habitat quality or quantity on the x-axis, and we can draw the relationship to fish reproduction on the y-axis. There seems to be reasonably good data that we've lost significant oyster cover in this state. We've lost some of the lower salinity SAV cover, a significant amount. We've lost some of the high salinity SAV cover. Just in case of the high salinity SAV cover, I think this scales to perhaps over, and there's experts here that could correct when we get to that point, but I think it's, more than 10,000 acres of seagrass habitat that we've lost during the 2000s, a non-trivial amount. We're seeing water quality closures. These are big dings on habitat. Why can't we quantitatively say what this is doing to our fisheries? What piece of the fishery puzzle is this habitat? I was talking with Nate a couple of days ago, and he allowed me to sort of pontificate. There could be other comments on this. If I wanted to put water quality on the x-axis, I don't even know what the units are. I don't know if the units would be PFAS or water clarity or turbidity or chlorophyll A. And it's likely to be some sort of, PCA-ish multivariate thing that could be put on the x-axis. But to me, not even knowing what the units are, again, I am trying to reflect. This is a serious challenge. I think we have an issue in terms of how we communicate with the legislature about how we move this ball forward. All right. So we've already submitted a summary report for this fishery study. And one of the major findings is that, yeah, we know that we've lost the habitats. That part we're starting to get, quantitative numbers on. We wish we had better numbers. The part that I've kind of highlighted here is, but we lack the quantitative links between habitat amount and fishery production. And I think that until that we can come closer to that graph, it's going to be harder to make cases for the state to spend money on the important things it needs to spend the money on to improve water quality or to restore seagrass or to conserve marshes or oyster reefs. And so some of this is a challenge to us to find a better way. And I think part of it, and I'll come back to this, part of it is a forum like this, a forum like APNIP. We need to leverage that to work together. One clear voice, grand experiments. I think that's a part of the puzzle we've been lacking here. All right, so that first part, I'll call that part one. That's maybe upsetting, or you're scratching your head for why you showed up for this. I have two more parts. I do want to reflect on some things about habitat and fisheries that really do worry me, and that I think at least motivate us to gain strong inference. It seems an imperative. Some of the things I'll show here in this part come from our big synthesis study, but I'm also going to draw from some other pieces that I just feel like I know. You sort of see it here in this little outline. So a little bit is about where we sit in terms of our fisheries, and then there are just some data about habitat-related linkages or issues that I'll scroll through pretty quick. So one of the things that we've done in our survey is we've asked, well, how strongly are North Carolina's fisheries being managed? Does the fisheries apparatus in North Carolina appear to have all the pieces that you would want to be able to manage effectively? And so what you're seeing in the left-hand panel on the x-axis is time, on the y-axis is essentially a score of the management intensity. This IMI is an index of management intensity. And the management intensity of North Carolina stocks has been high, and it's only getting higher. These fisheries are reasonably intensively managed. That's through stock assessments, that's through the FMP process, it's through public comment, it's through all of the gears that that we have come over time to believe are fundamental to the ability to manage strongly. On the right-hand panel, what you're seeing is kind of a very broad brush overview of how our stocks are faring. And over the last 30 years, or since the passage or implementation of the Fisheries Reform Act, it looks like we're kind of treading water. We've got some stocks that appear to be not doing so well. We've got some stocks that may be doing okay. We haven't found a way to gain ground. So even as the management has been getting, you might say, stronger or more intense, the results are just not what we would hope. And there are different ways to look at the status of our stocks. I used a very just sort of color-coded way. There are more quantitative plots of that we have of the relationship of current biomass to the biomass at MSY, or to our current harvest rates relative to the harvest rate that would achieve MSY, that might make you feel like, we're even losing ground in terms of the health of our fisheries. So what explains this disconnect? What explains how our management seems to have good pieces and it's getting stronger, but we're just not getting the outcomes that we want? And it certainly does occur to me that the quality and quantity of our habitat could be a big piece of this. And again, I'm now speculating. That's just frustrating to me. So coastal development there on the right is going up dramatically. Water quality parameters such as chlorophyll A in Pamlico Sound or Albemarle Sound appear to be shifting. Certainly in Albemarle Sound, and Nate, again, I'll lean on him. He's an expert in this. At the same time, that bottom panel on the left highlights that after about 2000, we've somehow found a way as a state to do less water quality monitoring. So the amount of active monitoring stations that are routinely monitored has decreased as opposed to gone up, even as we're continuing to have higher development rates, or at least more development, I should say, along the coast. And I looked at some data that Nate provided just a Saturday, and you could argue that Pamlico Sound is largely a non-monitored system, except for the periphery sound. And so there are some areas that we certainly need to get all on the same page to voice concerns to the legislature about how we might tackle not only uncertainty in the ecological dynamics, but just the lack of ability to collect data to even maybe gain certainty. So I'm going to, again, tell you some things that I see that relate to habitat and fisheries that I think are in the purview of APNEP and lots of people on this webinar. And the first relates to oyster reefs. I'm curious if I can get my cursor to hopefully, does anybody see a laser pointer point? Okay, right. So within estuaries, we really find oyster reefs in two types of environments: across salinity gradients and across the subtidal to intertidal exposure gradient. And in really salty places, we mostly have intertidal reefs. And in more brackish places, that's where we tend to have subtidal reefs. And a lot of our systems are seeing big shifts. These are data just from the Newport River. The Newport River is close to where I work. There's a long record of ecological and environmental research in the Newport River. And historically, the Newport River has been really important as a place of oyster harvest, wild harvest, and leasing and trying to grow shellfish. And what all of these graphs say is that salinities in the Newport River, they have been going up through time. It is a system that is getting saltier. Some combination of sea level rise, channelization, better drainage that gets fresh water out of the system more rapidly, perhaps. All these things are adding to a saltier and saltier system. And so within this Newport estuary system, what that means are two things. Well, it means one thing that I'll add a second. There is a line that happens in most estuaries. Seaward of that line, you'll only get intertidal reefs. Subtidally, oysters can grow, but all of their enemies grow really well. That's boring sponge, predators, tunicates, algae that smother them. So landward or upstream of this line historically is where you can get subtidal oysters in the Newport River. That line has been moving upstream over the course of about 100 years as the salt salinity increases in this system. That's happening at the downstream end. On the upstream end, since the late 70s, what we've seen is we've seen permanent water quality closures. And so this is just a fact of people living at the coast and our inability to keep water quality at a sufficient level to have safe seafood supplies. And that line has been marching down the river. And so 100 years ago, you could grow and harvest subtidal oysters from this part of the Newport River estuary. And as of today, this is the region that you can grow and harvest subtidal oysters in the Newport River. It's a big reduction. Someday you can even imagine those lines may cross, right? Now, the ability to put oysters in bags or cages means we can still grow oysters in some places that are even downstream of this line. That can happen. Those oysters are in bags and they're not out in the field long enough for the baddies to come in and destroy them like would happen with the natural reef. However, these permanent closures, these permanent shifts, I could also map on top of that the temporary closures. And I don't have data for the last couple of years, but I do know that in approximately 2020, 21, 22, this system, the Newport River estuary, stayed closed for basically half the year because of the periodic water quality closures that happen after every rainfall event that meets some critical threshold. So we're seeing both a spatial shift and a temporal shift in when we can access oysters in a system like this. And it's representative of certainly other systems, not all, but other systems in this state. These are data on sedimentation rates that we are seeing in our tidal creeks. So again, if you're in the Carteret County area, it's places like Ware Creek or Sleepy Creek or Tusk Creek. And if you're to our south, it's places like Hewlett's Creek or Gales Creek or Pages Creek as you approach Wilmington. All of these systems are seeing much higher sedimentation rates today than we would have seen 70, 80 years ago. This seems to be a function of how we're using the land. And as we change the way the land is being used, some of that sediment is making its way to these tidal creeks, making these tidal creeks in a lot of cases much muddier, somewhat gunkier. Why do we care about this? Um, these are data that DMF has collected from a long-term survey of designated nursery habitat areas in North Carolina. These are often sort of Tidal Creek-ish areas. And the long-term catch per unit effort based upon those surveys of juvenile fishes, this is things like spot, croaker, flounder, also blue crabs and shrimp. The overall abundance of juvenile fishes and crustaceans is going down. There seems to be, if not a strong relationship, perhaps a relationship between sedimentation rates and decreasing catch rates of these juveniles. There's a lot of noise here. Again, I don't have a smoking gun. That's part of our frustration, or at least my frustration. On this panel, what you see here is the responsiveness of individual species to higher sedimentation rates. Do catch rates go up or do catch rates go down as sedimentation rate increases? And things like shrimp, blue crab, southern flounder, pinfish, which are just numerically dominant, they all tend to be taxa that don't respond well in terms of their catch rates tend to go down as sedimentation rates go up. So how do we, and again, in a quantitative way, link this into a management decision about catch rates or the way that we manage the coast in terms of development or whatnot? I've seen people on the webinar that have done this work, the authors of this work, they'll know it well. Seagrass cover, this is high salinity seagrass, high salinity SAV. Cover is changing in this state. We have slight, I will say, annual decreases in seagrass cover, but they add up over years. We've also seen really large shifts in seagrass cover in terms of seagrass going from what may be graded as contiguous to patchy. So how does this shift in the nature of our seagrass translate to our maximum potential catches of blue crabs or some fishes? If we don't know that, how do we convince legislatures they need to act such that we keep the high functioning system that we want to have? I'll just show you a little bit of data from some experimental stuff we did here locally. So what you're seeing here is you're seeing seagrass meadows that we've mapped. We have some seagrass meadows that are small but contiguous, some that are large but contiguous, some that are small and patchy, some that are big but patchy. And what these data would say, if you believe these data, is that if you've got plenty of seagrass, it doesn't matter if your seagrass is contiguous or patchy, you can support the same richness of fishes and crabs and shrimps. However, if you get below a critical threshold of cover within some domain, well, now having your seagrass transition from contiguous to patchy means that you could well lose species. These species, for whatever reason, either choose not to occupy those areas or are not able to occupy those areas. And so again, how do we turn these kind of small experimental data into something that's big and quantitative and valuable at the state level? I think it's going to require coordination and working together to come to some more profound understanding about these large scale phenomenon and the impacts they have. I gave a talk a while ago that was kind of a cheerleading session for North Carolina seagrass. I do think this is neat and interesting and perhaps important. I've been a part of a few studies that are global in scale, where we all go out to our seagrasses and we ask, well, how does our seagrass function compared to seagrass in California or Japan or the Baltic? And what I would like to highlight here is that if you look at the consumption rates of little prey items in seagrass meadows across the globe, whether it's Northern Hemisphere or Southern Hemisphere, all the green dots are data from seagrass meadows in different parts of the world. North Carolina is an extreme outlier in terms of there is a lot of action happening in our seagrass meadows. There is a lot of trophic transfer. There's a lot of fish that are nibbling and being nibbled within these meadows that ostensibly moves energy up the food chain to the fishery species that we care about. This was one study published in a fairly well-regarded journal. This quote is from an entirely different paper, an entirely different experiment, again in a decent journal. And what it says is, it says that the density of fishes in your local environment, in your local seagrasses, really scales strongly. I think this score of a 0.42 to me means something ecologically, given how variable nature is, with how much consumption there is. And North Carolina has a lot of little fishes. If I showed you the catch rate of little fishes in a North Carolina seagrass meadow, we are just as high as anywhere on the planet in terms of the density of little fishes that our seagrass meadows support. So what does it mean if we're losing this habitat at the scale of several to even tens of thousands of acres? And then lastly, this is just a synthesis. And what this is looking at is, what are contaminants doing in sort of coastal systems, some aquatic, some saltier. This is a meta-analysis. So what you're looking at is, you're looking at a metric called an effect size. If data are above the 0 line, what that means is consumption rates in predator-prey interactions, consumption rates go up. And if you're below the 1-to-1, if you're below this 0 line, it means consumption rates go down. So consumers are less effective in finding and attacking and acquiring their prey in the presence of these contaminants. And these contaminants include ocean acidification, or metals, or microplastics, hydrocarbons, pesticides, or these personal healthcare product type things. And pretty much across the board, what you see is all these contaminants that we have appear to be working to decrease consumption rates. They are decreasing trophic transfer. And so we've got this system in North Carolina where trophic transfer rates appear to be really high, probably are important in supporting our fisheries. And to the degree that we have contaminants coming in, that could be dislinking that trophic transfer, but in a way that I'm kind of having to wave my hands. I mean, this is like one study, or it's a one meta-analysis. It's not coordinated at the state level to really clearly address this focal question, which is what I think we need. So then part 3, how might I argue that we move this ahead if we're going to be science driven? And I've stole this from someone named Nancy Knowlton. This isn't mine. But we do need to reflect that what we can't do is, we can't just sit here and complain about things are getting worse. Martin Luther King was effective, not just because he had a profound message, but he knew how to deliver that message. He didn't stand on the steps of Lincoln Memorial and say, I have a list of complaints. He said he has a dream, right? He has a vision. He has somewhere that he wanted to take society. And I think that's what we're responsible to do as well. Like, we need to work together. We have great academic institutions. We have great state partners. We have a strong management engine. We need to find a way to, in one clear voice, more effectively tackle these big questions, the main questions. Maybe working too individually, I'm chipping away at the corners too much. I need your help. We all need each other's help to probably get the attention of North Carolina on the big things. So what do we have to build on? I think chances to talk like this are important, but we have to have legs. This couldn't be the end of it. I was really impressed at something that this Water Quality and Fisheries Symposium accomplished in 2024. So not in 2025, but in 2024, what I'd like to point out, if you can follow the laser pointer, is that this fellow is the head of the Fisheries Association, the Commercial Fishing Association of North Carolina. And the fellow bisected right here is the head of the Recreational Fishing Group, the CCA. Getting these two people in the same room under a shared desire, a common concern of habitat and water quality, that's big. I spoke to both of those gentlemen in the summer of 2025 repeatedly. The last time they were together in the same room was at this symposium in the fall of 2024. We have to find ways to leverage these groups that sometimes are at odds, but fundamentally they have the same goals. I think a sustainable coast, habitat and water quality is a huge part of that. They're on the same team, whether they might admit it or not, in this case. So I think we've got to find a way to help them connect. They struggle sometimes to connect for reasons you're probably aware well of. So this speaks to another major finding of our synthesis project for the state's fisheries. It does seem very clear. I don't know that you could get a more clear signal that there are certainly opportunities for better engagement, um, deepen trust in the management process, and clear exchanges between stakeholders and managers, stakeholders and academics. Um, how do we get there? How do we do that? I would want to say a big part of that is to work together on experiments. We have an opportunity to design and plan some big projects. And if we did it collaboratively, we're never all going to agree, even on what the data mean, but at least we would develop a working relationship and I think better trust. And, pretty much every name that I see on the webinar so far, I mean, we serve the state, we serve the citizens of North Carolina. I think we all want to be engaged with them, hand in hand. We want to be objective. We want to have the ability to let the data be the data, but that doesn't mean that we can't partner better, I think, than we seem to have. So I think we ought to have forums where we figure out a vision for the big experiment. And I think the big experiment has to be designed to answer this question. Can we, with any quantitative certainty, tell DMF, tell legislators that if they can conserve or restore water quality or habitat, they are going to get this many fish, ballpark, right? They are going to get this much economic return. They're going to get this much value. Because I can certainly guess, I think this is true, the developer can tell them that how much a development project is worth. A developer, and developers are not our enemies, right? But they've got numbers on jobs and on economic impact. And all I can do right now is say, well, oysters are important for fisheries. Oh yeah, how so? Well, they're just important. And that makes it, I think, hard for legislatures. That would make it hard for me if I were in their shoes. So the time is now. I mean, we know what's happening at the coast. I don't think we've got 2 or 3 decades if we want to get ahead of this. We're already a bit behind. And so I feel a real sense of urgency. Maybe it's because I'm mid-career uh, and I can sort of have some scope looking backwards, and I know I can start to see maybe a finish line. But I would love to start making progress on this in a more fundamental way. We do have a foundation. I think North Carolina deserves tremendous credit. There's a bit of like visionary action here. North Carolina has this coastal habitat protection plan. That's a unique and valuable thing. I love thrumming through it. I'm generally always impressed. I think what the chip doesn't have, I've said this for a while, but I know other people say it too. What the chip doesn't have is teeth. So this is an analysis that's part of our synthesis. So if you look at the component pieces of what the chip is recommending, you can score those proposed actions as either complete in green and progress in yellow, or not underway or not sufficiently underway. And in the areas of research, I would say, well, yeah, we're not really effectively moving the ball forward quickly enough. I would actually highlight the restoration one as not being sufficient, because I think my opinion is the CHIPS goals are far too meager. So right now they're able to say things are underway or happening, and I don't see anything at the scale of thousands of acres. And I think until we start to have that conversation about thousands of acres of habitats or major water quality shifts, we're maybe rearranging some chairs on the big ship, so to speak, without naming the ship. The monitoring mapping part, I highlighted the trends in the water quality monitoring. I think we're not doing enough with that monitoring. These are long-term trends. You got to have long-term data. There has to be investment. And so there's a bit of a chicken and egg. How do we get the data until we can have those hard numbers to convince the legislatures there's a real issue? So that's something that creative people have to figure out how to tackle. I highlighted this one special because I was just embarrassed at myself. the morning that I gave this talk the first time, I didn't have this one start at all. How can I not have appreciation for the role of education and outreach? Like how lazy was I to not think about, yeah, if we're not communicating well enough and getting enough people on our side to have that one clear voice, that's just going to be a huge problem. And I do think it is a problem. So you might entertain the idea of something like this to give chip teeth. And it's kind of revolutionary in its own way. So right now we're trying to figure out, what sort of biomass to maintain in a system, and what sort of mortality rate that we can allow to kind of achieve that biomass. Well, what if we let the stock assessment people run their numbers and give us, whatever they think the suitable harvest rate is if we've got all of our habitats, and then at the end of that process, we do a calculation to figure out, but yeah, we've lost half our habitats. So now you can only catch half as many fish. This would, in a quantitative way, link habitat to fishes. This would quantitatively link the amount or quality of habitats to what we allow people to harvest. If I were a fisherman, do you know how mad I would be if this were to happen without really good numbers that link the amount of habitat to the amount of fishery production that we have? It would be a very difficult sell if I was a commercial fisherman or even a deeply invested recreational fisherman to have my harvest impacted by the presumption that habitat may be linked to fishery production. That would have to be based upon really good data, I think, before we could expect to get support for that. We don't currently have that sort of teeth in the management process. We don't, at the end of the day, say, well, hey, we know we've lost half our oyster reefs. Oyster reef is an essential fish habitat. So if it's essential, that has to mean we've got to decrease the harvest rate by some amount going forward, because we can project what the habitat's going to be. So to begin to close up shop here, I think I'm about on time. Sorry if I've been long-winded. These are some other recommendations that are in the report. The final report's due at the end of this year. Again, the summary report is already out. I think these all speak to things that APNIP and APNIP stack members care about. Recommendation 3 is, how do you move towards an ecosystem-based management approach? How do you holistically look at the health of our fisheries? How do you link in those habitats and inform fisheries management? And Dean or others can correct me, but when I was on the stack, there was a phase where there was a list of indicators that scaled to the several hundreds of possible indicators, and I really struggled with what to do with that. I've only recently kind of glommed on to maybe how that could be effective. So if you had a group that met and they could agree on, well, these are the most key parameters. Like, yeah, what we really need to know is how much CDOM there is, or we really need to know like how much PFAS there is, or we really need to know how much seagrass habitat there is, or low salinity SAV. If you could have that group really focus the state to go after those key data, I don't think we currently have that group that provides us that sort of holistic insight. And so this is, sort of something I think AppNet's been on the trail of for a long time. And in our own way, I think our report would support that. Recommendation 4, in the absence of good data that links habitat to fish, what we do have data on is that we're losing the habitats. I don't think we can wait a couple, 3 decades to figure out some of the solutions for at least doing large scale restoration. The restoration itself would be an experiment to see if it links to fisheries. If we could restore thousands of acres of a habitat and then at some scale log the fishes, that would be a very novel, powerful experiment that fundamentally we just haven't had the ability to do without the support to go big at scale. And then, in terms of a habitat context, water quality context, land use context, I'm pretty concerned about these shifts that we're seeing in the designated nursery areas. They were designated in the 70s. I mean, again, very visionary, extremely visionary, to protect juvenile fishes. We're maybe not protecting those fishes as well as we might have liked based upon these data. And there's lots of nuance and lots of things we could talk about what these data mean. But I think North Carolina has, they set these things in the 70s and they've done a lot of monitoring. There's been very little reevaluation or assessment of, are we getting what we want out of these designated areas? And so I think some focused conversations about those habitats and how we manage not just the fish, but again, the development on the coast is important. And then the last thing, I think this is the last slide or maybe two, is I just think we need to find a way for all of these, great coastal scientists, APNEP, NOAA colleagues, DMF, the Coastal Fed. We all need to pull in the same direction. I think we need experiments at fundamentally big scales, at the Newport River scale, not at my bucket scale, at my 10-meter plot scale. Maybe the water quality people are ahead of us, the way they sample, the ecologist. We work at too small of scales. And I'll just use the shrimp trawl example here. Our report is fundamentally not about shrimp trawling impacts. That is beyond the scope of what we did, but it's been in the news. I think we all know it's been in the news. My point here would be this. I learned over the summer, because I happened to find them, you can go to the newspapers in North Carolina in 1949, 1950, 1951, and the same conflagration about shrimp trawling existed then as we saw this summer. We are now 75 years into this debate about whether or not shrimp trawling is the worst thing or not a problem at all. 75 years. And what that screams to me is we have failed to design the experiments at scale to get the right answer to that question. And so until we find a way to do that and push on the legislature to give us the support to do it, are we going to be 75 years down the road still having this food fight about, is shrimp trawling the worst thing ever or perfectly okay? Oops. All right. So with that, I appreciate the chance to come here and talk. I know it was a bit of a zany talk to start with. Hopefully it's somewhat valuable. Again, I want to thank colleagues and I want to thank all the different people that have funded this work, especially the North Carolina Collaboratory. They're the link between the legislature and the researchers that's provided the time and resources to do the synthesis. All right. Sorry if I ran long.
All right. Thank you, Joel. And I just want to know where the sign-up sheet is, because I'd love to have a chat with you, give you some updates on some of those perspectives. But anyway, is there anybody in the audience that wishes to pose a question or a comment to Joel? Put up your... Okay. Wilson.
Yeah, thank you, Dean. Can you hear me okay?
I can. Very good.
So, Joel, thanks for the presentation. There's some interesting insights in there that you provided, and I'll look forward to discussing some of those with you at some point. With respect to the shrimp trawling issue, thank you for that historical observation that that's been going on for 75 years. I mean, you can, like you said, you can go back to papers from the 1950s and 60s and see that the same issue is there. I recently ran across a paper that I shared with some folks, and I don't think I shared it with you, but it's a very interesting one. The title of it is Disturbance Recovery Dynamics Inform Seafloor Management for Recovery. And I think it has some potential direct application to us here in North Carolina, in particular with respect to oysters and SAV, but also to, I think, the recovery that would happen if we could shift repetitive trawling, out of our sounds and estuaries and offshore. And I was just wondering if you thought that such a shift might result in some recovery. And I'm thinking in particular, recovery not just of oysters and SAV in places where it would be appropriate for them to reestablish, but also just in the kind of bottom structure, sand ripples and so forth and so on, and also sponges and other types of structural creatures that might reoccur in Pamlico Sound if we could move trawling offshore. Do you think that's a possibility?
Yeah, open that door with the trawling. Such a spicy meatball. Sorry if this is a bit whiny answer. So one thing I would note that's different in those stories from 1950, 51, 52, the only real structural difference is at that time it was commercial fin fishermen who were mad as fire at commercial shrimpers. Nowadays, it's obviously the rec side that's more concerned about the impacts, and the commercial side tends to be a more unified sector. All the other fundamental dynamics about the way the scientists played a role, what scientists said, it echoes strongly of today. That's my opinion. I do not know the answer to any of your questions. This is why we need the experiments at scale. Anybody, I have a tremendous amount of respect for you. Most people I see here, I know you and have respect. If you tell me you know what was going to happen if we were to ban shrimp trawling, and you tell me you know it, I'm going to say, no, you don't. You're guessing. You may have a good hypothesis. You've got a good theory. I have my own suspicions. I think it is interesting to think about the possibility of closing shrimp trawling in areas that historically oysters could grow. And is it possible that we do not see recovery of oysters because those areas do get dragged periodically? I like it in that it's a testable idea. Let's go do the experiment. What would be required to do the experiment? I am extremely skeptical that shrimp trawling is the problem that seagrass is experiencing. I do not believe that Reed Corbett's data on the nature of water quality disturbance after trawling shows that I should be worried. I don't think the trawlers are intersecting the grass. The trawlers are out there at night, and the sediment, to my eye, has largely fallen out by daytime. So I'm not terribly worried about light attenuation. But I don't know. I do not know, and so I would start with the northwest quadrant of Pamlico Sound. I have been fairly impressed at the potential dangers to weak fish populations, just the distribution of weak fish in Pamlico Sound and the overlap with significant trawling. I would say there's an opportunity for an experiment. And I even think the commercial sector would have some interest because they're just, this thing comes back up every few years. If we could devise an experiment to provide commercial fishermen, a reason to be willing to evacuate that quarter of Pamlico Sound for some period of time, if we could provide the incentives to allow them to buy into that, we could do a major test of maybe not the effects on habitat, but at least the effects on weak fish. And if we see no signal in weak fish populations after 5 years, we should probably own up to that. And if we see major benefits for weak fish, we should own that as well. We have to have the will to do this experiment. Otherwise, you ask good questions and I can't answer until we do the experiment.
Oh, thanks. Yeah, a good response. And Lewis and I have kicked stuff around a lot about, whether or not we could compare the North Carolina's Pamlico Sound, where you have really intensive repetitive trawling for a long period of time, with adjacent estuarine systems like even Albemarle Sound or Chesapeake Bay. But the problem we always run into is we don't have, comparable fishery independent data from those systems. And the other thing, of course, about Albemarle Sound is it from a salinity regime perspective, it's totally different than, well, not totally different, but a good bit, significantly different from Pamlico Sound. So like you said, the ideal thing would be to have an area such as you suggested, that particular corner of Pamlico Sound that you could close, because at least that would ensure that you have a lot of similarity between the areas that would be open and continually trawled to the area that would be closed, and theoretically would begin to show some semblance of recovery, at least from my perspective, in trying to define recovery as, the fact that the bottom is no longer being plowed by otter boards perpetually. And so theoretically anyway, you would begin to see some development of some sort of bottom structure and some sort of infaunal communities that might resemble something that was more historical in scope. I don't know.
Yeah.
But
My,
thanks for
my only position is that I could bore all of y'all for the next 3 hours with a point counterpoint. I've looked at enough papers. I've been around enough where I can give you, hey, this really concerns me about shrimp trawling. Hey, the way this is handled a stock assessment makes it seem okay. I could go back and forth and back and forth and back in my own mind. But we've been doing this for 75 years. Can we stop doing this and actually get together on an experiment that would allow us to move forward? Are you going to get everybody to agree with the outcomes of an experiment? No. But I think we can get over 50% to sign up in a fair way, in a transparent way, make this happen.
Yeah, well, I agree. It would, if we can design an experiment like that and get buy into it, that would be great.
Hey, Joel, I have a question, I suppose, talking a little bit about restoration and scale. And just, I guess the question there is are there examples in North Carolina where we're close to the scale you're talking about? If not, analogs elsewhere? And then for the lack of any instances in North Carolina, I mean, what can we do to move in that direction, not necessarily at scale, but to glean from the restoration that's been done?
Yeah, so I guess if I were going to start, there's a group called the North Carolina Marine and Estuary Foundation, and Chad Thomas is an important player. I really like what I've heard him talk about. I need more details, but they are proposing to go in at the tidal creek scale. So this is places like Hewlett's Creek to our south. And they want to do like a major restoration of that scale. So that's not thousands of acres, but it's big. And if they can demonstrate, it's almost like, it's like a replicated design. Each of these tidal creeks is a replicate, and so I think there's real power in that. I would propose to probably start there. And whether or not the restoration is all focused on water quality or all focused on oyster reef creation, just do it at the tidal creek scale, not the typical 60 bushel scale. That's not big enough. It's a pinprick. I have, and this is, right in your wheelhouse. What was the spawning sanctuary network and now is the oyster sanctuary network in North Carolina. It's remarkable, and it's an experiment, and it's been powerful. It's probably not big enough. I mean, right? If you put them to scale on the map, they're absolute pinpricks. What a challenge! What a challenge! So I don't think you can necessarily start there. I would say tidal creek scale. I might even be able to go to Newport River scale. And so here's a for instance. And look, again, our study is not a shrimp trawl study. A lot of our contentiousness in the state revolves around gill nets and shrimp trawls. So maybe it's natural that we come back to those. Shrimp trawlers, commercial fishermen will say these systems are dying because we don't drag nets there like we used to. And these systems need us. And these are people I sometimes know and respect. And I'll tell them to their face, like I'm telling you, I'm like, just stop it. This system existed for thousands of years before you got here. Like, stop it. However, there is a new player in town, which is this sedimentation rate that we're just dumping in. And so, in fact, you may have a point. It is an interesting idea that if we could let you go in there and you could remobilize those sediments, what might happen? Now, those sediments don't disappear. They go somewhere. They go downstream. So it's not all, rainbows. But I think that's an experiment that we ought to be open to. if these P&As are becoming clogged and there's the opportunity to replicate the experiment to try things like that, those are the scales that I think we have to work at. So I'm kind of not full of crap. I think I'm talking about a big scale, but I'm not crazy. Like thousands of acres, we're not there yet. We got to show some progress, and then we can build towards thousands of acres.
Yeah. Point well taken. Yeah, and I guess the other thing just about messaging, when you're talking with legislatures, the sediment thing. I guess I tell people now, if I could go back to it, I would have gone to school to model how sediment moves, because you can make a lot of money that way, I think. But like we've constantly said, sediment's an issue, yet we tell them that our marshes are starving and sediment starved, right? And so your tidal creeks are perfect players for this. Whereby, yeah, the channels are probably sediment, but the vegetation adjacent isn't. And so, yeah, okay, yeah.
I think that's a great. So I don't have answers, but I've wondered about that, because in a sediment-starved system, why isn't there some value? But the grain size, the nature of the sediments, and just where it's ending up in the middle of the tidal creek, as opposed to can we get it in the marshes?
Right.
Those are all things that are a bit, I don't know, but I think you're onto something there.
Yeah. No, thanks for the talk. Really enjoyed it. Appreciate you spending time.
I'll keep digging my grave with one more thing, and I'm going to dare one of y'all to prove me wrong. Y'all would know. In terms of river systems, I think there's some decent data about the value of buffers. But I was talking with a guy named Bob Worth, who's a world-class seagrass ecologist, and later in his life, he's become like a regional commissioner in Virginia. And they were talking about estuarine buffers. And what he was telling me is, he was saying, well, we got to have these buffers. And some developer said, well, why? What do you actually know about how big of buffers we need? And Orth said, he scoffed and said, come on now. This is well worked out. In fact, I'll go find the papers. And then Orth went to look for the papers, and he's like, I don't have any good papers on how big estuarine buffers should be. Like, it is theoretically possible that buffers need to be 1 mile deep. That's possible, because guess what? We don't have the data, according to him. And this is why I challenge y'all to prove me wrong. I'm happy to learn that there are good data. I'm not anti-good data. But I think we've got some opportunities here. Like, we have some scope to do really neat things at scale. And that's the joy of the job, is to be helpful with those types of experiments. But also send me a bunch of papers on buffers if you have them. He told me that he was shocked he couldn't find much, and he's a good scientist, so I presumed that he was not crazy. And that's different than riverine buffers, just so I don't get in trouble with anybody.
I think you're on mute, Dean.
Sorry. I was saying we were going to shift to Bob Orr's former home down up at Vim's. Donna?
Yeah, thanks, Joel. Yeah, I just wanted to comment that there is a model for doing such a large scale experiment that you're suggesting, which I agree with. The NOAA has this program called Habitat Focus Areas throughout the U.S. I don't know if you're familiar. So there's now 2 of those in Chesapeake Bay. So Choptank River and Middle Peninsula. So these are focusing on these larger tidal creek watershed systems with targeted restoration and research, fixated in a 5-year period in the region. And a lot of what you're talking about is sort of the goals. I will say the program's imperfect, but you can petition to be a habitat focus area. So identifying an area to do such an experiment, I think, would be a great use of that program.
Thank you. I made a note. I do need to do some more. I knew the Choptank, but I did not know the other one. What was the name of the other one? I didn't even know that.
It's the Middle Peninsula, so it's it's actually several waterways, but it's close to Vim's. Includes Mobjack Bay and the York River.
Okay. Okay, I see a hand from Bill.
Joel, I'd be real happy to talk to you about buffers at some point. There, I would actually agree with you. There is no real definitive work on what an estuarine buffer would be, but there is a substantial amount of work on buffers for various potential impacts, and each buffer is different for that. So if you're talking nutrients is one, it's sediments for other, there's soil type, elevation, vegetation structure, all those things impacted. You can't just set a buffer of saying 100 feet for estuarine shorelines or something like that. It depends on the impact in the shoreline.
Okay. I know we're going a little bit over time, but it is certainly worthwhile, these kind of questions. Any more? Okay, Bill, again.
Joel, also thanks for your time this afternoon with our stack. I really appreciate it. I know the members here appreciate it too, and there were specific requests for this talk from numerous members. So thanks again.
Well, if anybody would like to talk more about the gory details of the synthesis study, Nate's right there. He's happy to talk to anybody.
Okay. Well, if there's no other further questions, all right. Well, Bill took my on behalf of AppNup staff, but again, I'll do it anyway. Thank you, Joel, for sharing your insights on the study, and we look forward to gaining access to that full report. I guess will be coming out either end of this year or early next year, right? All right. All right. Well, thank you all for attending. Great conversation, and have a great rest of the afternoon.
Yeah. Thanks again, Joel.
Thanks, Steve.
Sure.